Good day. Today we want to look at properties of limit. So why properties of limit? We need it because when calculating limit of function using calculator, so we tend to make or do mistakes. So in order to avoid such mistakes, okay, so there are some guiding law in mathematics that will help us to evaluate the limit of functions seamlessly. Okay, so these properties are of many kinds depending on the operation at which the function has. Okay, so let's start by giving the law one after the other. Suppose C is a constant and the limit of this function as x tends to a is L1, meaning the limit of this exists and it is L1. And the limit of another function g of x as x tends to a is L2. So suppose these two limits exist. So two functions f of x and g of x. We have that limit to be L1 and L2, where L1 and L2 are real numbers, meaning the two functions are defined. So we want to state the limit as follows. Then one, the first under the property is sum and difference law. It states that if we have the limit of f of x and g of x with operation either addition or subtraction as x tends to a, what this means is that this limit operator will act on f of x and it will also act on g of x, and this will give us the limit of f of x plus or negative the limit of g of x. Okay, so by the supposition here, you have that the limit of f of x is L1 and the limit of g of x is L2. So this is what referred to as the sum and difference law. Also, the second law is the limit, if you have the limit of a constant, if C is a constant, okay, so the limit for any x here is that constant. Okay, so what we mean here is that since the variable of operation here is x, what this means is that there is a variable at the back of this constant which has variable x. Okay, but the power of that x is 0, and because of that this will be 1. Okay, so what you are saying in essence is this. So what you have here, the limit of this constant is like this. So the variable of operation is is a is x raised to the power of 0. Okay, so if we apply the limit on this, though this limit, what it means is that whenever we see x, we should substitute a. Okay, so if you do that, this will be a raised to the power of 0. And by law of indices, this a raised to the power of 0 is 1. So c times 1 is c. So this is the second property. So the third property is the product law. This says if we have the limit of two functions, f of x and g of x, which obey the product like this, Okay, again, this limit will be distributive on the function that we have here. That is, this will be the limit of f of x and the limit of g of x. Okay, so maintaining the product here. So by our supposition, the limit of this is L1 and the limit of this is is multiplied by L2. Okay, so maintaining the product as well. So the next one is referred to as the scalar multiplication. If you have a scalar or a constant c like this, multiplying a function f of x, okay? So again, if you apply property 3, this means this limit will operate on this and it will also operate on this. So we have this. So by property 2, the limit of a constant is a constant. Okay? So, and the limit of this by our supposition is L1. Okay? So at the end, we have the scalar multiplying the limit of that function. So the next one is the quotient law. This arises if you have the uh, function f of x over g of x like this. Okay, again, this limit we act on f of x and it's also act on g of x. So this gives the limit of f of x divided by the limit of g of x as s tends to a. Okay, again, this will be L1 divided by L2. Okay, and for this limit to exist, this must come with the condition that the denominator here must not be 0. Okay, it must not be 0 for each x. Okay, so the next property is the power law. This says that if we have the limit of f of x all raised to the power of n as x tends to a, here this n is a positive integer. Okay, so what it means is this limit will go in here to act on f of x, and this will be the limit of f of x as x tends to a. Okay, so this will be this, and by the limit of this is L1. Okay, so here this must come with the fact that n is a positive integer. All right. Okay, so this is referred to as the power law. The seventh property is called the root law. Okay, so this is opposite of this. Okay, and it is given as this. If you have the limit of the nth root of f of x, okay, again, this limit will go in here to affect this. So this will be the nth root of the limit of f of x as x tends to a. Okay, again, this will be the nth root of L1. Okay, or the limit L1 raised to the power of 1 over n. Okay, again, this n is a positive integer. So again, we label this property 8. But here, the limit we're about to say are special cases. The case where our f of x is defined as, for example, if f of x is equal to x, okay, then we can have that the limit of x as x tends to a will be equal to a. So this is referred to as a special limit, okay? Instead of f of x here, we replace f of x with x here, okay, which is a linear function. So we apply this limit, okay. We have a since we will have x here, okay. So the next one is one of the limits which generalizes, okay. So this one says if f of x is equal to x to the power of n, where n is a positive integer, okay, then again we have that the limit of xn will be a raised to the power of n, okay. So these two limits are special cases, and they usually involve in the first seven limits we defined above. So again, one of the special limits is if f of s is the nth root of x, then the limit of nth root of x as x tends to a will be equal to the nth root of a, or a to the power of 1 minus n, okay. So the 10 properties we have discussed here are the first properties of limits at finite value of x. So you see that we usually use x tends to a. This a we are referring to a finite value. Okay, so later we'll consider some limits and the properties of a limit of infinite value. Okay, with the assumption that the first 10 properties that we have discussed here also hold for limit at infinite value. Now, we want to consider these four examples to illustrate the properties of limit we earlier discussed. So we'll be taking this one after the other. For the first one, we have the limit of 2x squared minus 3x plus 4 as x tends to 3. We also have a rational function whose numerator is a cubic function and denominator is a linear function. We also have another function that's trigonometry, the limit of sine cube of x as x tends to pi over 2. We also have another one, the limit of the fourth root of x squared minus 9 as x tends to 5. So let's see how we do this with the aid of the limits law. So solution. So here we are given this, okay. The first thing to do here is to apply the first law, which says the first law, which that's a sum and difference, which says that when we have a function of this form, where this is a function, this is another function, this is another function. So this limit will be applied on each of the function as follow. So this will be the limit of 2x squared as x tends to 3 minus the limit of 3x plus the limit of 4 as x tends to 3. Okay, so what we have done here is that we have applied the first property, which that's the sum and difference law. The next property we'll apply here is property 4. That's the scalar multiplication. You observe that this is a constant multiplying a function. Okay, so by that property, this limit will not affect this. Okay, so but this will be 2 the limit of x squared minus this also look like this. So apply property 4 to this also. So this will be 3 the limit of x as x tends to 3. And here we can apply property 2 directly, which says the limit of a constant is that constant. So by that property, this will be 4. Okay, so we can evaluate the remaining limit. Here, this is 2 multiplied by 3 square minus 3 into 3 plus 4. So this will be equal to 3 square is 9, 2 times 9, that's 18. Okay, 3 times 3 here is negative 3 times 3, that's a 9 plus 4. So this is a 8, 18 minus 9 plus 4. This will be equal to 13. Okay, so here we have applied about 4 properties. The first one is sum and difference property. So we use that to split the first thing here. Then secondly, we apply limit of a constant, which is the constant. Okay, then we now apply the property we have in 8, property 8, under the special limit. So again, in the second example, okay, this is the case where we apply the quotient law. It's quotient because this involves a rational function. Okay, so by the property of the quotient law, which is stated in property 5. Okay, this is this limit. Okay, we go for what is in the numerator here, and this is and this limit will also go for what is in the denominator. So that's the first property to apply here. The next property to apply is the properties, that's property 1, properties on sum and difference law, which says this limit will be distributive on each of these items. So this will be equal to the limit of x cubed plus the limit of 2x squared minus, so I'm managing this one here. So this will be limit of minus 1. Okay, as s tends to negative 2, s tends to negative 2. Okay, everything over the limit of 5 as s tends to negative 2 minus the limit of 3x as s tends to negative 2. Okay, so again, the next property to apply is that's property 2, which says the limit of a constant is a constant. At the same time, we can apply the properties of scalar multiplication now to bring these 2 out and these 3 out. Okay, so other ones are direct. Okay, so let's do that. This one is direct because there is no scalar here, so we can compute this directly. So that will be minus 2 raised to the power of 3. Okay, we are doing this because there is no scalar here. Any that is a scalar, we'll bring the scalar out before we substitute. Okay, so this will be plus 2 the limit of x squared as x tends to negative 2. And here we apply property 2, as we have said, 1 is a constant. So irrespective of what the operator here will, it will remain 1. Okay. So again, this is a constant. So the limit of a constant is also a constant. Okay. Here we also have a scalar here. So the scalar can come out first. So that we have 3 limit of x as x tends to negative 2. Okay. So finally, we now apply our special limit in the 8, 9, or 10 there. So to this and this. Okay. So this will be, okay, we can compose this directly to have minus 8. Okay. Since the power here is odd, so negative 2 raised to the power of 3 will be that. Okay. So plus 2 into negative 2 square minus 1. So everything here will be 5 into this. Okay, so the denominator here is 5 minus 3 into negative 2. Okay, so here we can compute this directly. When we compute this will be negative 2 raised to power 2 will be 4. Okay, 4 times 2, which is 8. Okay, so here this will be negative 8 plus positive 8. Okay, that will be 0. So negative 1 is the remaining items there. Okay, so in the denominator here we have negative negative, so and then that will be positive. 3 times 2, that will be 6. So if you add everything together, that will be 11. Okay, so the denominator here is 11. So the limit of this function is negative 1 over 11. Okay, so that's the limit of this. So let's go to the third property. So for example 3, so we apply the law in under the item 7. Okay, so here now to apply the law. Okay, so you see that this sine cube x literally means the limit of sine x all cube. So this is like f of s when compared to the property 7 we discussed earlier. So this limit will go directly for this, and this becomes the limit of sine x as x tends to pi over 2. So the power comes in here. So we can apply this limit to this function directly, and this will be sine pi over 2 raised to the power of 3. So when you use the calculator now, sine pi over 2 is 1, okay, raised to the power of 3, okay, and that is 1, okay. So 1 raised to the power of 3 is 1. Okay, so that's the we only apply property 7 here. Okay, so property, let's look at example 4. So this one 4 is all about the property in item 8. Okay, this one says if you have the limit of the fourth root of x squared minus 9. Okay, according to the property in 8, so this means the fourth root of x squared minus 9 x tends to 5. So here we can apply the sum and difference rule in item 1. Okay, so when we do that, this will be the fourth root of the limit of x squared as x tends to 5 minus the limit of 9 as x tends to 5. So here we can apply limits, the limit law 8. we apply the limit law of 1 here. So before we can put, so this becomes 5 square minus 9. Okay, the fourth root of 5 square minus 9. So this means the fourth root of 16. So taking the fourth root of 16, okay, so this is a 2. So the limit of this function as x tends to 5 is 2. So this is where we'll stop. Now next class we'll be looking at limit at infinity, some of the properties we have underneath.